Alrighty, good evening everyone. So, I got word that my 3D printed press tooling video got posted to Hackaday, and it got a lot of exposure, and it seems like you guys were pretty stoked with the way I did this kind of stuff. And so, I believe it was Ryan Flowers at Hackaday wrote up the blog, and he did a pretty good job, and thank you for sharing my work. I've said it a handful of times, but my whole goal with building and filming this whole process is I really want to teach other people that they can do this kind of complex, difficult work at home with minimal tooling and with minimal experience, as long as they're careful and they take their time and they do good measurements and they check their work, right? So I'm very glad to get some more exposure, and I really hope I inspire some other people. So please, if you're going to utilize some of the similar press tooling, if you're going to try 3D printed assisted milling with the router, please let me know. I would love to see it. Now, like I said, pretty much everyone was stoked to see this stuff. So thank you. However, there was one commenter on the blog that was not very happy, I guess you could say. So I'll throw up a screenshot here. Go ahead and pause it, read it if you want to. This dude was not happy that I was going to all this trouble to make my 3D printed press tooling and 3D printed milling jigs. Then, yeah, fair point. You could do this way faster if you have a CNC mill or even a manual mill and proper press tooling and a press brake. I don't have that. I'm in a horse barn and a shipping container on the other side of the yard, right? So, no, I will not stick to prototyping and art when I make my car parts. I'm going to continue 3D printing to do what I need to do, you know. So whatever, you know, it just makes me laugh. This guy was just not happy. Maybe he runs a shop and he doesn't want any competition from home builders figuring out how to do this kind of stuff without, you know, paying shop time. I don't know. So today's little video is going to be a quick one. I ended up brazing the copper tubes, the aluminum plate, and you know, I'm just being reminded that I'm not an expert, especially not on brazing. It's been a long time since I was like officially taught how to braze, so kind of relearning the process. And we'll go ahead and flip this camera around. I want to show you some close-ups, and I'll show you a couple little time lapses of what I did, but there's really not that much to it. So let's take a look up close, and we'll see what I did here. All right, so here is the aluminum plate with the copper tubes in it, brazed in. Let me show you a couple close-ups. So I am not a brazing expert by any means. And this plate is marred up just because of the vise I was using. That doesn't matter for the function of the part further down the road, and we'll talk about that in a little bit. So, rookie mistake number one. I didn't use anything to clamp these guys in. I assumed once they were set they would stay, and that was the wrong assumption. I began heating on the middle, and the second one was one of these two. At some point during that process, this guy decided to heat expand out of the hole and give itself a huge gap over here, and basically no gap over there. And so that made this guy angle out and was crooked. So that really sucks. So rookie mistake number one, don't do that. That sucks. Rookie mistake number two. So when I went to go straighten it, I put this guy back in, what I should have done, and I clamped it from the midsection, and I used my hammer, roll some of that footage, to straighten this guy. Now when I did that, that induced a bending moment between the two, between the jaws over here and where I was torquing it over here. So that, oh man, I wish I hadn't done that. So there's a little bit of wobble in the plate from that now. Later on, I clamped from here, and well, that puts all the bending at the joint here rather than allowing it to twist across a length. So that sucks. I really wish I hadn't done that. So if you're going to do something like this, clamp your tops tight so that these things don't walk. So that really sucks. Rookie mistake number 3. When I was hitting this guy with the dead blow hammer, one of the blows glanced and bumped this guy. You can see the dents. If you look close, this thing is not wanting to focus. You can see the dents in the side of the thing, and I've kind of tapped them out as best I can by hand. However, we're going to need to try and put this guy back in there and tap the outer surface gently with the hammer to try and bring that back into square. So that sucks. Don't do those kind of rookie mistakes. I've done some straightening work on this plate, and it's getting better. That amount of wobble is not that bad, but you can see the gap under it. So gotta fix that up. It's too late, and I can't hammer too loud because it's just way too disturbing. Wake up the neighbors. Yada yada yada. When that guy walked out, it made this thing way crooked, not even close to aligning. Where we're at now, after reflattening a little bit, which brings it back a little bit out of alignment, full disclosure, right? We are really, really darn close. Let's get that light on. All right, so these two are friggin' dead on. No trouble there. Tap those into place, and they are good to go. These guys are where I need them to be. It's this one. So these guys did great. So next time I do this, I'm not gonna leave these these pieces of copper free to explore the world and go wherever they want. So let's pause. Clearly, I need to work on my one-handed skill with my left hand. Okay, so rookie mistake number 4. So I had wrongly assumed that I wanted to keep this guy on a nice flat surface to help give it a nice even heat flow throughout to help keep this guy on a flat surface on the bottom. Now that may have been a valid assumption when I was prototyping and testing on the thin plate. However, when you get to this thick a plate, the amount of heat you have to add in here to get it up to temp is really high. So this is the container, and we need to be between 800 and 900 Fahrenheit in the base material. So that amount of heat in this thick a plate that's a lot of heat, and the heat transfer is going to be flowing up and out through these heat sinks, and having a big steel heat sink underneath, it's going to be drawing a ton of heat energy out through the bottom as well. So what I did to solve that is I ended up taking a bunch of random bolts and stuff that were all the same size, and I would stick them under here and set it up on top of that to give it an air gap so that it doesn't heat transfer straight into the steel. So once I switched to that, it was so much smoother, and the aluminum got to temp, and it was actually flowing appropriately. Now I could very easily get the copper to temp, and I could melt the braze on the copper, but as soon as it would touch the aluminum was too cold. So I ended up going through like probably half a bottle of acetylene, and I'm out now. That is a dumb rookie mistake, is not knowing how to properly apply heat into the workpiece and wasting like half a bottle of acetylene. So try not to do that mistake. That one sucks. But yeah, that's I think that's it for the rookie mistakes. So we're getting pretty much the end of my talking portion of this video. So I'll probably roll in a little bit of time lapse of the brazing process. Brazing is not the most exciting thing to watch, so I won't waste your time with that. Oh, however, before we end it off, got a little teaser for you. In the next video I'm going to put out, I will teach you the method I use in order to obtain precise dimensions with a complicated multi-feature assembly with hand tools. So and obviously 3D printer assisted. So I will teach you that guy in the next video. That'll be another quick one. But yeah, that'll come out later. All right, that's going to be it for today. And I appreciate you watching. So see you all next time.